that is a reality of what is happening right now. This is automation, just like it happened to the auto industry and so many other industries. It's now coming to construction. So we need to prepare for that. And that's why we created our curriculum, because we believe we can create far more jobs than are being replaced.
Welcome to the Fine Homebuilding Pro Talk podcast, a regular discussion with building industry professionals. This is Senior Editor Patrick McComb. Today I'm joined by Zachary Mannheimer, founder and CEO of Alquist 3D. You can find the Fine Homebuilding Pro Talk podcast and the original Fine Homebuilding podcast at finehomebuilding.com/podcast. You can leave feedback and ask questions there too. Zach, it's a pleasure to have you on the show. Thank you very much for being here.
Thanks. It's a pleasure to be here.
I'm sure our folks have no idea what Alquist 3D is. Can you please, Alquist 3D, can you please tell folks what you do?
Sure. We are a 3D printing home construction company. So our mission is to create housing that's affordable across the country to solve the affordable housing crisis that we've had for decades.
So my observation of tech startups is they don't often target the entry level. Affordable is not a word that I hear often in new technologies. Why did you guys decide to enter this space instead of something, say coastal, where concrete construction perhaps makes a lot of sense for, storm reasons?
Well, we're certainly still doing coastal, but the affordability is a problem everywhere. Even if you live in a community where the median home price is $1 million like California, affordability is still a problem there. But our primary locations that we're targeting are rural locations. Average size community is about 3,000 people. We are doing that specifically because we have another company that I co-founded many years ago called Atlas Community Studios that does creative placemaking, economic development, and workforce development in rural communities in 27 states. So we help these towns rebound from years of being overshadowed by their sister giant cities. And how do you attract and retain younger people to want to even come to these communities? What needs to happen? And that means amenities, infrastructure, childcare, hospital, transportation, et cetera. But the number one issue in all of these towns is housing. And so for years, we've been trying to figure out how to solve the housing crisis. I discovered 3D during that process as a way to drop the cost of housing across the board, because in my opinion, there's really only two ways to solve this crisis. Either companies need to pay their employees more so they can afford the rising cost of home building, or we lower the cost of home building, or ideally both. But since we don't have any control over what companies do, we focused on how do we drop the cost of housing. 3D is not the only way, but one great way to do it. And it's been 6 long years to get to where we are today, fighting to make housing more affordable.
And you recently completed your first home in Richmond, Virginia. Can you please tell me about that project?
Sure. So the Richmond home was a collaboration between us and Virginia Tech and Virginia Housing. We worked with Virginia Tech to get a grant to do the first 3D home in Virginia. So that home is, the printing was completed last summer. The home itself will be completed in the next couple of weeks and sold. But the second home that we printed was the one that is now the only 3D printed home in the world that has a family living in it. And that's the one in Williamsburg, Virginia, the one we did with Habitat for Humanity.
And I have a bunch of questions related to the technology and the process. But first, I want to ask you about your background, because you have a background, I would say, is as far from construction as one would typically think. You're a theater major, right?
That is correct. I was a theater and philosophy major, so I had absolutely zero job prospects when I graduated.
So how the heck did you get involved in this? I mean, you mentioned that you were looking for ways to solve the affordable housing crisis, but how did you even get into that interest?
Yeah, it's not a normal class that you take in affordable housing when you're a theater major.
In philosophy, I'm sure you'd agree it is discussed, right?
Oh, sure.
Yeah.
Absolutely. But my goal regardless of what I'm doing, has always been to create community. For the longest time in my 20s and early 30s, the goal was doing theater. So I grew up on the East Coast. I grew up outside Philadelphia. After I graduated college, I lived in London for 2 years, and then I was in New York for almost 10 years. In London and New York, I produced theater all over the place. Of course, I had another job at a restaurant because that's how you do it.
Because you have to.
Yeah. But the goal of our theater that we were always doing was very much pushing the envelope for change. and trying to create community. And the goal really was, how do you get two different people who don't agree on normal major topics, who come from things from complete opposite viewpoints? How do you get those people to form a relationship? We were using art and theater specifically as a way to bring people together. I left New York in 2007, and I wanted to move on to a smaller community where we could impact more change, but also a place that was not so homogenous. I lived in Brooklyn, and everybody looked like me, thought like me, acted like me, ate like me, etc. And it wasn't very healthy as a human or as an artist. So I did a cross-country road trip to 22 cities. I was looking for where I was going to move, and I chose Des Moines, Iowa. And
Can I ask how you chose Des Moines?
Sure. So the demographics I was looking at, I wanted a city that was roughly 500,000 people in the metro, a city that what I would call a third city. If a Minneapolis or a Nashville or an Austin is a second city and a New York or San Francisco is a first city, Des Moines is decidedly a third city. And I was primarily going to third cities. And it was a toss-up between, I really loved Pittsburgh, I really loved Boise, I loved Reno, I loved Tulsa. There were a lot of different places I could have wound up in. But Des Moines checked my boxes. It was the right size. It had a downtown that was in need of revitalization back then. Now it's certainly completely revitalized. It struggled to retain and attract young people. It had an art scene that was burgeoning but not established nationally. And the best piece was, it was as close to 50-50 politically as I could find. So for all those reasons, I chose it. And I kind of said, well, if it doesn't work out, I'll move on to one of these other cities. But I quickly met my now wife, and we have 3 kids. And that's what happens when you move to the Midwest.
That's what happens when you move to the Midwest. So back to your company. What do you think are the advantages of this process? You know, you mentioned cost. I'm sure it's not any less costly right now, but your hope is to get there. Is that correct?
Yeah, it is and it isn't. There is a cost savings currently. It is not dramatic like we want it to be. And you're absolutely right that this is a long game, and we will get there. But today, what we know is that first home, the one that the Stringfield family is living in Williamsburg. So we know that we saved about 15% across the board if we were to construct that home stick built. And it's important to note that the only difference between that home and a stick built home is the exterior walls are concrete. That's it. Everything else about that home is identical to a regular stick-built home. We still need to hire local electricians and plumbers and HVAC and roofers, et cetera. So we know that we saved 15%, and we did that in 4 ways, three ways on the front end. We did it in terms of time. It took us 22 hours to print the exterior walls. Material, the concrete was less expensive than if we were going to use lumber. Labor, we only needed between 2 and 4 humans to operate the printer when we would have had a framing crew of between 6 and 12. And we shaved off about 3 to 4 weeks of construction time when we built that house by using our 3D printer. The 4th way we have savings is the concrete walls. A 3D printed concrete home uses 50% less utilities and energy costs than a stick-built home. So you've got savings on the long run as well. So,
I'm going to challenge you on that. I mean, I think, you know, a normal stick-built house, but the folks who listen to this show would argue that point. So I'm just going to make it so they don't yell at me or the iTunes or however they're listening.
Yeah, I would love to be challenged on it. So this is basically a report that Virginia Tech did with our first home, studying whether what the energy efficiency of these units are going to be. So those are the numbers that they came up with. And certainly we still need to study that further, but that's where we landed. On top of that, it kind of doesn't matter anyway, because all of our homes are going to be coming with a solar panel microgrid, a battery, and an EV charger. So we're going to be pretty close to net zero right off the bat.
That's fascinating. And the house we've been talking about, if I were to describe it, it had like 2, I don't know, they look like maybe 2-inch thick ribbons of concrete on the exterior, and then there's a cavity that's going to be filled with, in my understanding,
spray
foam insulation.
Yep.
And then there's an interior layer of concrete also. And it's a single-story home, pretty squarish. So anyone who's done a concrete pour, and there is probably most of the folks who listen to this show, are probably having just a panic attack thinking about the challenges of dealing with that much concrete in such a short period of time. I watched the YouTube video, 90-degree heat. That created some problems, didn't it?
It did. The biggest variable by far is weather. So we still have a ways to go to really understand the material science here and figure out the best formula to do this. Now, here's the biggest way that we can get past this issue. And absolutely, once we hit 95 to 100 degrees, the material fell apart and we had to stop printing for the day and we had to clean out the hoses. We lost a hose during that process on one day. So lots of challenges. Weather is the biggest one, and we have to change the formula based on what the humidity level is, et cetera. But the faster we can print, the better we can get past this issue. And this is really an OSHA problem for us, is that OSHA only limits us to printing 250 millimeters per second, which is slow. The printers.
I'm surprised. I'm sorry. I'm surprised to hear that OSHA has regulations on an industry that is so in its early stages.
It does and it doesn't. They're not, these regulations were not built for 3D printers. They were built for robots.
People pouring concrete.
Yeah, basically.
Yeah.
So it's a safety issue. And there's no major, if your printer runs faster, we're not endangering anybody. So OSHA knows this, and we're working on getting this changed. So it doesn't work for the industry. But the printers are capable of doing 350 to 400 millimeters per second. When we can do that, when we did that in our tests, the print came out so much better, regardless of the temperature. So that I wouldn't say it's a silver bullet. That's not the only thing that'll solve this. We're also looking into different types of material. So we're going to be using black buffalo material on the next prints that we're going to be doing in Virginia.
You have to tell me what that is. I'm sorry.
Yeah, so Black Buffalo is a company, Black Buffalo 3D. They are our manufacturer of our printers. We're going to be using their printer. They also make their own material, and they're the only ones that have their materials past the AC 509 globally. So it's already passed code in 80 some countries. That's incredibly helpful to us. I'm sure your listeners are going to question, how do you get something like this past city code, et cetera? Which,
that's one of my next questions.
Which is not, we'll get into that. It's not as challenging as you might think, but it is certainly a challenge. So using this material, it's already past AC 509. That's incredibly helpful. Also, this material is 7,500 PSI. So it's super strong. And when we've been extruding it in extreme cold and extreme heat in our tests recently, there has not been an issue. When we get above 100 degrees, it's too hot. We got to stop. And when we get below 36 degrees, I believe it was, it gets too cold. But within that window, we're okay.
It's fascinating. So what else can you tell me about the concrete for the nerdy people who listen to this show? I'm assuming it's something pretty special, and I bet there's additives that we're not even familiar with in that concrete, or is it something pretty standard?
It's pretty standard, honestly. I mean, there are additives to help speed up the drying or slow it down, and that's largely dependent upon the weather that we're printing in. But it really, I mean, you can use Portland to do this. You can use standard. I mean, the two homes that we did already, we use Quikrete. And so you can put additives in, of course, but it really isn't anything that special. But frankly, we are moving away from concrete. Concrete's great, but it's far from the most environmentally friendly material. So we want something that still fits the price point that we're trying to hit to make these affordable, but also is not producing a ton of carbon. Now, we already know we're reducing carbon because by using this technology, we have 90% less waste on the job site. So that's a big deal. But we're looking into plant-based materials using hemp. We're looking at using graphene. We're looking at using coal or fly ash. I wouldn't say we're anywhere close to this. We're probably a year or 2 years away from really having something that can pass code, number one, and number two, be structurally sound, and number three, be extruded properly through the printer. But we are working on it in several states right now.
So let's talk about the printer. It is a mother of a printer. It's the biggest printer I've ever seen. It looked like it needed its own concrete footings to operate. Where does that come from? Are there others? Like, does it come in pieces? How does that all work?
Yeah, so we've used two printers so far. We used a Cobod printer on the first two homes in Virginia, and we're shifting over to using a Black Buffalo printer for the prints that we're going to be doing over the next couple of years. The major difference is both machines are great. There's pros and cons to both. There's also, Icon makes a printer, Apiscore makes a printer, Seabay makes a printer. They make the robotic arm, although I think they have a Gantry that's coming out as well.
I'm sorry to interrupt you, but so are these the same companies that make like large CNC equipment for industrial applications, or is this a totally separate arena?
Totally separate arena. They only do 3D. So there's a handful of companies globally that we're in touch with most of them. I would say there's 12 to 15 companies globally that make a gantry style printer or a robot arm that's large enough to do a home that we think are good enough to be on the marketplace today that we could use. The hardware, there are minor differences. So something we like about the Black Buffalo is it's on a track system. So we can print multiple homes at a time. That's something we're going to be experimenting with this summer. Also, the Black Buffalo printer goes up 4 stories. Now, we're not attempting that. Nobody's ever printed anything that high. Nobody's gone above 2 stories. But we will be doing a 2-story unit in Pennsylvania in the fall. We're going to be attempting that. But ultimately, we want to go up 3 or 4 stories to do multifamily. And that's really where you're going to see significant savings across the board. Right now, we know there's going to be more savings when we can print multiple homes at a time. So the projects Alquist is taking on, we're not the manufacturer. We're never going to be the manufacturer. We are a printing company. And so we're not really a tech company. We're a construction company. We use the technology to build it out, but then we also hire GCs wherever we go locally. And we still have to bring in all the subs. Alquist 3D is the sub for the framer. But we still require all the regular electricians, plumbers, et cetera, on every job site.
So one of the things that immediately struck me when I saw this rig is like, a lot of construction sites are a complete disaster with regard to mud or topography or what. Like, can you set one of these things up on a hilly site? What do you do?
That's a great question. So at the moment, I would say no. At the moment, we got to clear it and grade it as flat as possible. So we're going to be challenged this year because we're printing in Appalachia and we're printing in super rural Eastern Oregon, and both topographies are very different. We're trying to find flat land, which we have found, but it's not going to be perfect. So I think the technology in the next 2 to 3 years will adapt to do grade, but I wouldn't use it today on anything that has a significant curve to it.
One of the things I was curious about is, the exterior walls on a normal stick frame house are used for pipes, electrical wires, all kinds of stuff, right? What do you do in one of these homes? Do you put it in the cavity between the skins?
You can. For the homes that we did, we put it all in the interior. But you can certainly put it in the cavity. We will be doing that this year. We're also looking at panelization technology, prefab tech. With that, it's already insulated and plumbed and ready to go, and we can drop those panels in. We believe the most efficient way to do a home today is to combine those two worlds. And this is really modular and 3D coming together, where we're printing on site the majority of the exterior wall or all of the exterior wall, but we're using the prefab panels on the interior.
I noticed on the homes I looked at that looked like someone had come behind and cut some channels or openings for electrical devices, lighting fixtures specifically. So yep. Obviously that's possible too, right? You can. There's
three ways to do that. So yes, you're right. The way that we did it was somebody came in when the concrete was still wet, and we cut that and we put the junction boxes in, et cetera. Another way is just to print it all whole and cut them out afterwards, which you can do, but not the most effective. But what is the most effective that we'll be doing this year is and this is really the beauty of this technology. You can program that all into the code no differently than a window system. So the printer knows to stop and not print when we hit a window. And then when we get to the top level, you put a steel lintel in and you print directly across it. You can do that. You can program the junction boxes where you're going to put light fixtures, et cetera, the doorbell. All of that can be built into the design itself.
I know the folks who listen to this are thinking, like, what about changing these structures after the fact? Can you just cut a new opening in a wall, for example? Does it have the strength?
Absolutely, it does. So,
yeah.
It's different than drywall, of course. But we are building this out. One design that we have right now that we're playing with is basically building a, I'm forgetting the word for this. The thing that you put on the back of a wall, so when you back your chair up into it, it doesn't hit
a chair rail.
A chair rail, yeah. But having that be a full, quarter
wainscot.
Thank you. Yes, that's what I'm thinking of. So putting one of those up, basically 18 inches up from the floor, that comes out 3 or 4 inches, and we run everything through that, and then you top it with a piece that can easily pop off if you need to fix anything. So. Cool. We're not doing that just yet because we don't want to lose square footage because we're doing very affordable units. But we're talking about that concept. We're talking about running everything through the floor. And if we did that, we can use panelized flooring instead of laying a slab. So I wouldn't say we have as you can tell, a specific answer for how we want to do this yet. We probably won't for the next 2 years. We're going to be experimenting with this. But the technology is getting better every quarter. It gets faster, it gets more complex, it gets smarter. And so our goal is to get to 30% savings versus stick built. We're not there today, but we believe that in the next 24 months we will be.
We'll be right back with Zach Mannheimer of Alquist 3D right after this message from our sponsor. This episode of the Fine Homebuilding Pro Talk podcast is brought to you by Jobber. If you run a home service business like painting, contracting, lawn care, or cleaning, your to-do list is endless, from hiring staff to mountains of paperwork, not to mention doing the actual work that pays the bills. Jobber is a mobile and online app that helps you organize your business and look professional. With Jobber, you can quote jobs, schedule your crew, invoice, and get paid all in one place. Try it free today at jobber.com. All right, so you touched on it earlier. Most of the homes built in this country are built using what we describe as prescriptive code. That means someone in an entity got together and decided what we were going to all agree was the minimum safest, minimum efficiency home we could build in this country. I suspect there's no code rules for what you're doing. Can you tell me how that works?
Yeah, it's really an education gap that we're finding. I mean, once folks understand that it's concrete. We've been building with concrete for hundreds of years. It's really no different than that. The major difference is instead of pouring it in a form, we're extruding it using a giant robot, which is weird. And so obviously people are naturally skeptical. I was too. I've lived with this now for 6 years, so I'm pretty used to it. But when folks hear about it or approach it for the first time, obviously they're, how does this work? So we explain it, we break it down, we show them the chemical complex and the mixture of what we're using, and they see it and they're like, okay, well, yeah, it's regular concrete. So we have not had a major issue passing code. It takes longer than it would if it was a traditional home, and certainly they visit our site more. But I think that's more out of fun curiosity. So I don't really feel code is going to be a barrier. I think the biggest barriers we have to this technology is just education. There's not a program nationally that teaches people how to become a 3D concrete printing professional. So we have to fix that for two reasons. One, we want to stand up the industry. We want to commercialize this. And that means we all need to play nicely in the sandbox. There's less than 10 groups nationally to do this. We all know each other. We're all friendly. There's no competition in this market, especially for a group like ours that's mission is affordable housing in rural America. We're not fighting over land with
Pulte or whoever, right?
Exactly. So that's good for us that we're not going to have really any major competition for years. But the commercializing this, we need 50 more companies to become like we are, just builders, not making the printers, although that's fine too, but builders to meet the need of the shortage that we have in America, which is anywhere from 3 to 5 million homes, depending on who you talk to. So you've got that issue. But then the selfish piece of this is that we need to hire a workforce. And there's no program that we can pluck people out of. So we've created it. So everywhere, we're going to be printing in 5 states this year. And everywhere we go, where we're doing more than 100 units at a time, we're going to be standing up a curriculum that we've created, mostly with community colleges. Some places we're working with high schools, other places with universities, but mostly vocational community colleges, which is where I think this belongs. It's an 8-week certificate course, no prerequisites required. Anybody can take it. It's 4 weeks in the classroom, 4 weeks in the field. Once you go through that, you are certified in our opinion, to operate one of these machines, and chances are we're going to hire you. And as more companies come online, this should become a very lucrative job market, and the starting salaries are quite good, especially for the areas that we're going to be in. Folks that come out of this program, they're going to start with the lowest will be around $40,000 a year.
Well, so what do you do in one of these jobs? Are your crew members physically loading the concrete hopper? You mentioned that someone has to be there to put the lintels over openings.
So you basically need 3 people to do this. We try to use 4 or 5 at the moment until we get really good at it. So your major positions are you need some, and these are the 3 tracks that people can study. They can go down the design piece, which obviously they're creating the G code, they're designing this. That's a more architectural standpoint. Those people aren't needed on the site, but that is a track that they need to go down. So they understanding CAD is helpful, but we can teach that as well. So you've got your printer operator, who is the person that can do it remotely, honestly. We don't recommend that yet. But they're the one literally running the printer like with a giant joystick. Then you've got your materials director who's monitoring the hopper. That is the person who's operating the forklift to bring this 3,000-pound super sacks and dumping it into the silo because we mix on site every few hours.
Yeah, we should tell folks there's not a batch truck coming.
Correct.
You're making concrete on site, which folks may be familiar with on large commercial projects. It's common to have a batch plant there, but this is probably something out of the ordinary for most of our listeners.
It absolutely is. So, excuse me. So you got three main pieces of equipment. You got your silo, you got your mixing pump, and then you have the machine itself. So they all work together. Frankly, the pump system is probably the piece of technology that requires the most ingenuity at the moment.
Anyone who's done concrete pumping will tell you that that's true.
Exactly. So that's the biggest, finding the right extrusion rate, et cetera. So that you've got one person operating the machine, you got one person manning the material pump section that includes putting the dry material in and then monitoring it to get to the right consistency that we need on that day, on that hour, depending on the weather.
So they're tweaking this, looking at the phone to see what the temperature is going to be in an hour, right? I mean, you have to.
We've got a thermometer right there.
Yeah.
They're taking the temp every 20 minutes. So they are very in tune with that. We're looking at weather patterns, et cetera. Then that's extruded all the way through a pump through the hose system and extruded out of the nozzle. You've got a third person at the nozzle head. We've got cameras everywhere so that both the printer operator and the materials director can see it inside the hopper.
You want to know if it stops printing for whatever reason, right? You don't want this thing to be wasting time, not doing anything, right?
Exactly. And so that for a variety of reasons. But that person in an ideal world is following along layer after layer, reporting back to the other two of what's happening in the hopper, extrude more, extrude less, a lot of it, depending on weather. Are we going around a turn? Are we making a curved wall? Monitoring that. And we've developed a nozzle head that fits directly on, that smooths the concrete as it prints. You have that ribbed look that if you look up 3D, that we can do that. That's if we didn't touch it, that's what it would look like. But we really like smoothing it for a variety of reasons. It's a nicer product, and it comes out looking almost like a stucco. So you can get by, I think, with 3 people, but having a 4th or a 5th person there to help out operating a forklift potentially, spelling people so they can take breaks. But in a perfect world, you're getting, in a 1,500 square foot home, you're getting 7-minute layers all the way around. And so in that perfect world, you can stand up one of these homes in a day.
Does it have to print round the clock? I mean, no, but I'm assuming you have to clean out the equipment, right? Because
you could print perpetually until you're done. In a perfect situation, and I've never been in that perfect situation, but technically you could, and the longer you print, the better for the structure itself. But we tend to go, we'll do 7-8 hours as much as we can. We'll stop, we'll clean everything out. It takes about 45 minutes to an hour to break everything down and clean it all out. You've got a heavy spray system there that does that, and then the next day you don't have to do this, but we put some bonding material down on the top layer for where we stopped before we start printing again.
And we should tell folks every so often there's like the kind of reinforcing that looks to me like you'd see in a block wall, right? Is it similar?
Very similar. So we use the ladder systems to reinforce every 10 to 12 layers. Those get placed onto the concrete. So that's another thing the 3rd or 4th human is doing. Is placing those directly into the concrete. They're cutting out the junction boxes, all those little pieces. They're cutting cold joints directly under the windows. Is something that we do, which we believe helps a lot to prevent cracking. Excuse me. So that process is taking place there. But you can print perpetually if you wanted to. And what's really great about this also is that it's super quiet. Typically, the loudest thing on the site is the generator. So we can start super early in the morning. We can go very late into the evening. We can do this with 2 crews and really pump this out as quickly as we can. And that's, the faster we do it, the more we get to that affordability range.
I have so many questions. This is so interesting. As a regular
Gotta come out
podcast,
to our sites. You got to come out
Yeah,
to our sites.
I want to see it totally. So our regular podcast host who joins me on the regular podcast, Ian Schwant's dad likes to say, it's 100% about money 100% of the time. So what do you imagine the final costs are going to be for once you get all the kinks worked out of this system? How affordably can you build a house, and is it really going to make a dent in this huge problem we have in this country?
Well, it's already making a dent. So it's a 10 to 15% dent. It's not huge, but it's still better, especially today with the cost of lumber, et cetera, and the supply chain issues that we're seeing. So that'll get better. We of course in time, but still we're not going to get back to pre-pandemic levels prices for lumber. That's not happening. So we know we'll always be well under that. When we can produce our own hemp-based material potentially and drop costs even further, that's great. But the major barriers right now, these printers, to your point that you made before, they're big and bulky. They're expensive to move and they're expensive to set up and break down because it takes a day or two to do that. We already know major improvements are being made by a number of companies to make these printers easier to set up and easier to transport. So that's coming in 2023, possibly earlier, probably not till next year. So that's going to drop the cost. When you're printing 20 or more at a time, you're dropping the cost. When you're printing multifamily, you're dropping the cost, et cetera. Row houses are great, ones that are perfectly connected. The Black Buffalo printer is great because it's on the track system. We can put one printer here and another printer here and move on down the tracks and meet in the middle and go this way. So these things haven't been done yet. And we're still at the bleeding edge of this tech. So I am completely convinced it will help save money. It already is. I think it is not the answer. This is not a silver bullet, but it is an answer to the affordable question that's out there. But I really like the idea of blending this world with the modular and manufactured world together. I think that's how we get to the real silver bullet.
Zach, do you imagine a day when your company and others like yours will own this equipment? Do you rent it? How the heck does that work? I mean, it must cost millions, right?
It's not, no, they're not that bad. The big Black Buffalo printers are about $800,000.
So that's a million. Okay.
Close. But that comes with the pump. It comes with the silo. It comes with the whole system. And most of the companies do that. And the price will come down, of course. You know, it's like if you bought a computer in 1978. So it's very similar to that world. So the prices will change. We both own and rent or lease these printers. So that is possible to do today. My anticipation is by 2025, most major construction companies will have a printer on site. It won't be replacing all the work. It'll be complementing it. By 2030, it can be replacing a fair amount. And that's something that we have to prepare for. And it's something and we like to say, this is not a disruption of the construction industry. This is a natural advancement and progression of the construction industry. And it is fair to say that we are replacing human jobs with robots. And that is a reality of what is happening right now. This is automation, just like it happened to the auto industry and so many other industries. It's now coming to construction. So we need to prepare for that. And that's why we created our curriculum, because we believe we can create far more jobs than are being replaced by this technology. It's also why we're called Alquist, which is a harbor back to my theater background, which is a obscure play from 1920 that no one's ever heard of, called RUR, was written by a Czechoslovakian playwright. This is the first piece of literature that coined the term robot. This is where robot comes from. And so if you do New York Times crosswords, you've probably heard of RUR for that reason. Otherwise, you probably never heard of it. But the plot of the show, not to do a spoiler here, but not that I'm worried about that. The man invents robots to speed up his manufacturing facility. Robots learn more on site and gain knowledge. They don't like their surroundings. They revolt and they kill all the humans. And so it's basically the plot of every sci-fi anything that happened from 1920 on. This is what started that. But there's one character, the main engineer, whose name is Alquist, who is the only human who believes humans and robots can coexist together peacefully. And so he is spared by the robots so that they can restart the human world and the robot world together. That is why we're called Alquist. We know every day that what we're doing, what we're participating in, but we believe we can create far more jobs than are being taken away. But that means we have to have a robust workforce plan, and we have to work together with our higher education facilities.
You we're talking about subcontractors, that you're not putting, tradespeople out of work in entirety. You still need plumbers, electricians, plasterers to do the stuff inside the house. Do you get pushback from subcontractors who look at this and they've never seen anything like it?
We don't get pushback. We get what I call optimistic skepticism. So they are excited by it. They are naturally skeptical of it. But I got to say, the places that we're printing in, most of these places, they haven't seen a new home go up in 20 or 30 years. So they're
happy to have any house, no matter how it's made, right?
Absolutely. And we want to deliver a well-made, affordable home for them and create as many local jobs as possible. Again, this is all about creating community. And you can't create community if you don't have anywhere to live.
So how are the interiors and exteriors finished? You mentioned that your ultimate goal is to kind of finish the exterior so it looks like stucco and it's a done deal when it comes out of the extruder. But what do you do on the inside?
On the same thing. We smooth it or not. That's up to the end user. And that's what's great about this tech is you can customize it. Now you can have a customized home for $250,000, $200,000. You don't have to drop $500,000 to $1 million to have a customized built home. Next year, you're going to be able to go online to our website and design your home online. It's very easy to do that. People ask about basements all the time. And the basements with this tech are irrelevant because the only reason why you want a basement is for structural, for safety. Well, it's a concrete home. And it's far less expensive to add 500 square feet onto the printing site of the first floor or second floor than it is to dig out and build out a basement. So
folks who live on mountainsides will tell you there are other reasons that you need a foundation, right?
We put foundation in, absolutely. Yeah. And for mountainside homes, things like that, absolutely. And I'm saying all this from my basement right now. So I get the appeal of basement. But when it comes to being affordable, that we have to take a look at that is we have to drop the cost of housing. It is far out of control. The median home price in America today is $347,000 for a home. That price is out 80% of the American marketplace. It does not work. The American dream is broken. It's been broken for 30 years. We have to restore it. So this means change. And change is hard. I get that. But that's what we're trying to bring to the table. But how do we do this in the smartest possible way? And that's working directly with the people on the ground who are going to live in the homes.
So you touched on it earlier, but I'm going to ask for further clarification. So, concrete, those in the sustainable building world have mixed feelings about concrete. It's a useful material, as you point out. It's very strong. It resists water, unlike most building materials. Mm-hmm. But there's a huge carbon penalty associated with concrete. Can you talk about that?
That's exactly right. That's why we want to be away from concrete within the next 2 years. I don't think we'll ever get 100% away. I think we'll always have some of that in our mix for sure. But that's why, like I said before, we're looking at hemp heavily. We're looking at coal or fly ash. We're looking at graphene. There's probably other pieces that we'll be looking at over the next couple of years. We're partnering with several universities to do these R&D studies to figure out what is the best mix for the environment. I don't want to be carbon neutral. I want to be carbon negative. I want our homes sequestering carbon as they're living and breathing. So we have a ways to go before we get to that level, but we're already making headway on it.
So here's my favorite part of the show. Can you tell me about your own house? I know you have a basement, but I'm guessing you don't live in an Alquist 3D house because there's two. What's your house like?
My house was built in 1988. It's in so I live in Iowa City. So just outside downtown, north of the highway, if you know Iowa City. So Iowa City is a university town. University of Iowa is here. Go Hawkeyes. This is everything is ruled by that wonderful institution. So our home was built in '88. It's stone. It's a little under 5,000 square feet. Full walkout basement, which is my office where I am right now, amongst our kids' playroom and many other things that are, if you looked over this way, you would see absolute destruction of toys and everything. And 2 floors. It's pretty traditional. Right before this, when we were in Des Moines, we lived in a home that was built in 1892, an old Victorian that we loved. And I love older homes, but After living in that for a long time and so many others, and frankly, one wasn't available when we moved out here, we're happy to not be constantly repairing the home itself.
Do you like that work? Are you handy yourself?
No, not even a little. Again, my background does not lend to that. I am probably the last person you want running a construction company, so that's not a great thing. I have learned a lot. I can be handy now. I can do drywall. I can do little fixes around the home, but only recently. I've learned that in the last 2 years.
How did you learn that stuff? Well, that's a conversation that I'm having with my coworkers.
My own team taught me how to do it. I learned it by watching us build our homes.
It's been a pleasure talking to you, Zach. Is there anything you want to ask or tell our audience before we part company?
Simply that, check out our website, alquist3d.com. We're pretty active on social media, on all the social channels. If you follow our lead printer operator, his name's Ayman Hussein. He is a TikTok rock star. Our posts on there, his posts, I should say, on there get millions and millions of views. We want more people in this industry. I should mention that Alquist, we're now offering a license to communities or companies that want to produce these homes for areas that we can't get to. Demand is absolutely crazy. Ever since we announced our Habitat home right before Christmas, we've been averaging anywhere from 50 to 100 requests for homes per hour.
It took me this long to get a chance to talk to you. You've also been overwhelmed with media requests, I'm sure.
It's been great. I mean, we're very thankful for all of that, but it's conversations like these that I really enjoy, where you can really break this process down because it is hard to understand. You think about a 3D printed home. What does that even mean? It's a terrible term for what we're even doing.
Yeah. You're making a concrete house would be how I describe it.
I agree. Yes.
Yeah. Well, I hope you'll keep us posted, Zach. I'm very curious about this, and I think it's a great thing you're doing. Super interesting. It scratches all my nerdy itches, I got to say.
Well, that's good to hear. And I would invite you and anyone else out to our job sites. Watch our posts. We're going to be making some pretty big announcements starting in March for the projects that we're going to be doing over the next couple of weeks, or the next couple of years, rather. We love people coming out to the site to view it. It kind of looks like you're putting up a rock concert when you put up the gantry. People think it's going to be for a lighting rig. But we invite anyone to come out, see it in person, ask us questions, reach out to us. We love to talk to everybody. We get back to everybody. And we're really excited to be a part of this brand new industry.
Well, and we'll put the YouTube videos that I watched in preparation for this interview up on our podcast page so you can check out how one of these things goes together. And Zach will tell you what the challenges are in developing a new technology. And, concrete gives everyone goosebumps when they hear the word, right? So.
Yes, it does.
Well, unfortunately, that is all the time we have today. Thanks to Zach for joining us, and thanks to all of you for listening. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And don't forget to like, comment, or review us however you're listening. It helps other folks find our podcast. Stay safe, everybody. Keep craft alive. Happy building. Thanks, Zach. That was great.